Okay, so it would be good if you had tried the 2 questions I gave at the end, and here are the answers to them. So you can pause the video to look at the answers and see if you got them right. But basically, a bracket to a power, we call the inside u, take the derivative, and then try to rearrange the derivative so that it solves for everything else, the x cubed and the dx. Then we substitute in, take the integral of the new simplified integral, and then put the u back in. And I did the same thing here. Okay, so we're going to do a couple more of these and the next type, fractions, in this video. So, the first example, and I just am adding these because I realized I didn't do these bracket to a power in the last one, so I'm just going to show you now. So this has a bracket to a power. There is nothing out front, so we're not seeing the derivative of this out front, but remember this is linear. So the same rule applies. If you call that u, the derivative of it is just minus 3. We don't need a number, so the derivative, we're just trying to get rid of dx. There's no other x here, so we just rearrange this to solve for dx. There it is, so we would put this in. So we have u to the 4, and instead of the dx, drop that off, and in its place, du over negative 3. Bring the negative 1/3 out front. So negative 1/3, integral of u to the 4 is u to the 5 over 5, plus c. 3 times 5 is 15. And u is 2 minus 3x, all to the 5, plus c. Okay, so I want to do one like that. So that had a linear argument, like the inside of the bracket was linear. And then the second one will do a fraction with a bracket to a power. But inside the bracket is linear. Same rule applies. Call u the inside of the bracket. The derivative is just 2. It's just a number. There's no 2 there, but that's okay because you're not worried about the constants. You just want to get rid of this dx. So rearrange so that the dx is by itself. Put your fraction. This is u squared. We call the inside of that u. Dx drops off, and in its place, du over 2. Bring that 1/2 out front. Now, to solve this, we need to bring the u up to the top. 1/2 is a constant. Integral of u to the minus 2 is u to the, add 1 to the exponent, minus 1 over minus 1. So this is minus 1 over 2u plus c, and u is 2x plus 1. So 2 times u plus c. And of course you could multiply this out, 4x plus 2 if you wanted to, but not necessary. There it is. Okay, so that was still type 1, bracket to a power. So the next type we're going to do is just fraction. So these ones, there's not very many examples for this because it's all just a fraction that doesn't have a bracket to a power, because I did hear some fractions with a bracket to a power. So my first example would be something like this. We've got a fraction. Okay, but there's no bracket to a power. So for this type, type 2, fraction, we're going to let u equal the denominator. And what we're looking for is the derivative of the bottom to be on the top. It doesn't have to be exact. Remember, the number itself doesn't matter, just the x, or the t in this case. So if we let u be the whole denominator, take the derivative of that. 5 is 0. Bring the 2 down, so 4t. Oops, not dx, dt. And go back over here. So we called this whole bottom u. And we just want the t and the dt to drop off. So here's the t, so that's good. And the dt, we'll rearrange this. So put your u in first, wherever it is. We're going to drop the t off, but there's still a 5 on top. So we're going to drop the t and the dt, and in their place du over 4. So bring the 5 over 4 out. And 1 over u, we don't bring that up to the top because this is ln. So this would be 5 over 4 ln u plus c. And u is equal to 5 plus 2t squared plus c. This is positive. It's t squared. You can't put a number in to make it negative. T squared plus 5. So if you didn't have the absolute value brackets for this particular example, because that whole thing is always positive, it wouldn't matter. But there's u is all of this, and I put it in. So we could have trig. And again, it's a fraction, so we're going to call the whole bottom u 1 plus tan theta. The derivative, du by d theta, is 1 is 0, tan is secant squared. And you notice we've got a secant squared here. So what we want, secant squared theta and d theta to drop off, those are the two parts that have thetas in it. We call this whole bottom u. So if we rearrange this, du is secant squared theta d theta. So there it is, the two parts we want to drop off. Call that u. Drop these. So I wrote the fraction line first. Don't forget to put a 1 up there if there's not another number. Drop these off, and in their place du. Nothing to bring out front, so this is just ln u plus c. And u is equal to 1 plus tan theta. There. And let's do one more example and then one for you to try. And of course, not all fractions are going to be done this way. So there's going to be tons that won't work. But I'm just purposely picking examples that will work. So we'll call that whole thing u. We go through lots of integration techniques, and some will work with types and some won't. But substitution is always the one you try first. So we call that u. The derivative of e to the x is e to the x. Derivative of 5 is 0. So we do have an e to the x and a dx. So write the u first. That's the whole bottom. There's a 2 on top, so we'll rewrite that. Drop the e to the x and the dx off, and in their place we just have du. So 2 ln u plus c. Put the u back in from up here, and we've got the answer. So I did 3 examples of these. Let's see if we can see them all at the same time. Not quite, but you can see the 3 answers. So here's the answer. The first one was lawn, the second one was lawn, and the third one was lawn. And all of these, we don't have a bracket to a power, we just have a fraction, and the bottom is not in a bracket. And we're always going to have lawn for those, if they work by substitution. Not all fractions are going to give you lawn as the answer, just if they work by substitution. Okay, so I'm going to give you one to try. Okay, so actually I'll give you 2. And actually, let's just add a third in here. Okay, bracket to a power. So bracket to a power, here's a fraction and another fraction. So I'll let you try these for a few minutes, and we'll put the answers at the start of the next video.